Welcome back. We are at the beginning of chapter 9. Chapter 9 is actually very similar to chapter 8, but now instead of dealing with a hypothesis test for one proportion, we're saying, what if we want to compare two different proportions? And so let's get started. So we're going to compare a claim about two proportions. The requirements, the sample proportions are from two simple random samples that are independent. NP hat and NQ hat are both bigger than or equal to 5 for each of the two samples. And the test statistic for proportions with, and this is going to be our null hypothesis, is going to be P sub 1 is equal to P sub 2. So we're going to assume the proportions are the same. The alternative hypothesis will say either that they're not equal or that one's bigger or smaller than the other. So and here's our test statistic. Again, thankfully, we have technology that allows us to not have to plug stuff into that. Example 1, in a study of burger drive-through orders, it was found that 264 orders were accurate and 54 were not accurate. For McDonald's burgers, 329 orders were found to be accurate, while 57 orders were not accurate. Use a hypothesis test to test the claim that both restaurants do not have the same accuracy rates at the 0.05 significant level. Okay. So let's start with our null hypothesis. And in this case, the claim is that they're not equal, which very nicely gives us a two-tail. Let's come up with our critical region. And because it's 0.05, that splits it up into two pieces. 0.025. And let's get our critical values. It's going to be inverse norm. Area to the left here is 0.025. And here we get our negative 1.96. And when we do the other, we get 1.96, positive 1.96. So for this one, to do our test statistic, we are going to run a two proportion z-test. So stat test, two proportion z-test right here. And x sub 1 is the numerator comparing the accuracy. So that's 264. The denominator is, these are the accurates and the inaccurates. So I'm going to add those together actually. 264 plus 54. For this next one, 329 were accurate. And the n is going to be 329 plus the 57. So 329 plus the 57. And this is a not equal to situation. And calculate. And very nicely, it does it all for us. It gives us that z is negative 0.80 looks like, which is going to be right out there. Our p-value is 0.4224. I'll round that off. The point is, this is way bigger than our alpha. So we are going to fail to reject. The null hypothesis. So there is not sufficient evidence to support the claim that the proportions are not the same. the same. All right, not too hard. Next up, we're going to do the same thing. It's the exact same scenario, except now we're looking for a confidence interval to confirm that. And what I'm going to run is a 2-prop Z interval. And I believe it saves all the same numbers in there for me. So let's find that stat test 2-prop Z interval right here. And it has all those same in there. And because it's 2-tail, we don't have to double it. Our C level is 0.95 because it's 0.05 significance level. So let's see what we get. So there's our interval. Let's write that down. So negative 0.0765. And 0.03222. Now, the assumption, hypothesis from up here, is that P1 and P2 are the same. Now, if P1 and P2 are the same, if I move the P2 over, then we're assuming that there's a 0 in there. And can you see that I'm actually going from a negative number to a positive number, which means 0 is in there somewhere. Which once again confirms that this is working, that we're going to reject the alternative hypothesis. All right. Example 3. A study of the number of cars that had both a license plate in the front and back of their car compared to those cars that only had a rear license plate was reported in the states of New York and Connecticut. In New York, of the 550 cars checked, 9 cars only had a rear license plate. In Connecticut, of the 2,049 cars checked, 239 cars had only the rear license plate. Conduct a hypothesis test and use a confidence interval, so we're going to do both, on the claim that New York and Connecticut have different proportions of cars with only a rear license plate at the 0.05 significance level. So our null hypothesis. Piece of 1 equals piece of 2. Alternative hypothesis, that piece of 1 does not equal piece of 2. And let's because it's not equal to, we have 2-tail again. And we just calculated out the critical values here. And let's get to our test statistic. Let's see if we got TS. So once again, I'm going to run 2-prop Z test. And the numbers I'm going to put in here are going to be, we'll start with the New York one. 9 only that out of the 550. And here we had 239 out of 2,049. Remember, n is always the bigger number. We have a not equals to and a calculate. Looks like Z is negative 7.107. Ooh, that's not good. P-value is, ooh, now it looks like 1.19, but it's actually times 10 to the negative 12th power. That means I have to move that decimal this way 12 places. So that means there are 11 zeros in front of that 1, and then a 1, and so on. So that's basically 0, which tells us to reject the null. But before we do that, let's run the confidence interval as well. I would expect that both boundaries are going to be negative or both are going to be positive, because we're definitely failing here. Let's go here. This is going to be, once again, 2 prop z interval right there. It has all the same numbers in there. Also 95%. Yeah, notice it's negative and negative. Let's write that down. So we are going from a negative to another negative, which means 0 is not in there. So 0. Either way, reject the null hypothesis. Meaning the proportions don't seem to be the same. And I would draw on the -7, but that's going to be way out here somewhere. So. The proportions are different. There you have it, not too bad. And notice the one test and the confidence interval, they complement each other. They actually give us the same accurate information as we move forward. This will be true for the other tests and the other sections. Thanks.